to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, just a reminder, some great news. The design of experiments for 21st century engineers, the Minitab version, has just been released. I know for those of you unfortunate enough to have selected Minitab, you have a great deal of difficulty in understanding this software. So we've created this special version of this text with the Minitab screenshots. The link to lulu.com where you can buy this book is in the description below. And of course, you also have the option of purchasing Drink Tea and Read the Paper, which is the perfect book to go with your green belt or Six Sigma black belt training. The link to lulu.com for that book is also in the description below. And of course, the other thing that we'd really love you to do, please go to buymeacoffee.com and make a small donation. All of these things, the purchase of the books and the donations, they help keep the channel moving. I'm really grateful to all of those people who are currently donating. Many thanks for your support and your help. And now let's get on with today's video. Welcome to the latest video. And in this video newsletter, we are going to take a look at how Minitab deals with the 3 probability distributions. So we're going to take a look at Minitab software, and in particular, what's the best way to do probability calcs in Minitab, and in particular, the 3 distributions that you're going to see at work: the binomial, the Poisson, and the normal. Why these 3 distributions? Because when you collect data, typically you are going to collect one of these 3 distributions. There are others in your business, but these are the common ones. If I'm honest, this one and this one is the common one. Whenever you look at data and you consider it as pass-fail, you're typically collecting a binomial distribution. Whenever you measure something, like measuring the weight of a Mars bar, you measure the grams, 50 grams, 49 grams, 51 grams, etc. Whenever you measure something, you're going to typically create a normal distribution. The Poisson is a bit more of a special case, but the Poisson is about arrival rate. So if you particularly have lorries per hour arriving at a tipping station for municipal waste, typically lorries per hour is an arrival rate, and you are creating a Poisson distribution. So they are the 3 common distributions that you tend to see inside most businesses, and therefore we're going to take a look at each one. And the first one we're going to take a look at is the binomial, then we'll look at the Poisson, then finally we'll look at the normal. Let's see how Minitab deals with probability. Okay then, finally then, we're going to take a look at the normal distribution and how Minitab deals with these calculations. Now the parameters in the normal distribution we're very familiar with. We're going to want to know the mean of the data set. We're going to want to know the standard deviation of the data set. So let's set up a little scenario. We have a supplier and they're telling us that they are producing a mean of 0.45 and they have a standard deviation of 0.1. That's what their process is currently producing. Now the target for this process is 0.5 of a millimeter, and the specification is 0.35 to 0.65 of a millimeter. They're making some fiber optic cable for us, and that's the current performance, and that's the current tolerance. So let's just draw that diagram. So we can easily just draw this. They're producing a normal distribution. They're centered at 0.45. They have a standard deviation of 0.1, so they're going to go 1, 2, 3, 1, 2, 3 in that direction. So we're going to go 35, 25, 55, 65, 75. Let's drop the tolerances on here. 0.35 is one of them, 0.65 is the other. So what we want to know is how much data falls in the left hand tail, how much data falls in the right hand tail, because that'll be the defect rate down there, that'll be the defect rate up there. Now, using the tool that we were using before, and we're going to continue to use the probability distribution plot, I can't get the answer to this on one plot. So what I'm going to do is ask it for a left hand tail calculation first, and then a right hand tail calculation second. Let's go to Minitab and get the answers. Okay, well, we're going to go to the menu as before, probability distribution plot, view probability, click OK. Of course, we've got to hit the drop down menu and select normal, and then we're going to type in the parameters. Well, we know we've got an average of 0.45 with a standard deviation, put too many decimal points in there, 0.45 with a standard deviation of 0.1. Now we need to go to the shaded area. Now the shaded area, of course, gives us the left hand tail request and the right hand tail request. So we'll do the right hand tail first. Now if you remember, the tolerance was out at 0.65. So if we put 0.65 there, click OK, then it works out the area in that right hand tail. Now I'm going to write that on the board. It's 2.27%. Let's put that on the board. So this tail, look, 2.27% above the top tolerance. Now let's go back to Minitab and get the left hand tail. Now we repeat that procedure. Probability distribution plot, view probability. Everything's all set up for us. We just need to change the calc. We're doing the left hand tail, and now we're going to put the bottom tolerance in there. Let's make sure I put the right number of decimal places in, 0.35, and then click OK. And now look, pop that out. We get the left hand tail, and now we've got 15.8 in the left hand tail. Let's just pop that on the board. Okay, so 15.8 goes in this tail here, 15.8%. So now this is the normal distribution predicting what the defect rate is. Remember, by the way, that the supplier never gave us any data. They only gave us the parameters. And then we are drawing an inference. We are making a prediction about the defect rate inside their organization so that we can judge how risky it could be that they're going to send us defects. So there's the normal distribution. That's how it will play out in your organization. The ability to predict going forward, how many defects are you going to make if you've got a mean and standard deviation that looks like this. So there are your three distributions, the binomial, the Poisson, and the normal, and that is the best way for Minitab to deal with them with the probability distribution point.